So in this lecture we are going to start the inelastic collision. In the previous lecture we have seen the elastic collision where there is no loss of energy. What is the elastic collision? You tell. Can you tell me? During the collision, the kinetic energy is converted instantaneously instantaneously in the form of the deformation potential energy. Do you understand or not? And all this potential energy is completely converted back to its kinetic energy. This is the V1, V2, this is the U1, U2. So there is no loss of kinetic energy or no potential energy resides in left inside the bodies. Are you getting? So this collision is called the perfectly elastic or simple elastic collision. But sometime what happened before collision, if u1 and u2 are the velocity, and when they collide, so deformation takes place, and the deformation takes place, and because of, and after that the reformation, when the reformation takes place, some potential energy stored inside the bodies, and therefore there is a loss of kinetic energy, and this type of collision is called the inelastic collision. Are you getting or not? Sometime what happen, sometime when they deform in a such extent that they does not acquire the original shape and size, so and they become the completely one body. No reformation takes place. The deformation is takes place but no reformation is takes place, and they move with the combined velocity, and this is called the perfectly inelastic collision. Is it clear? So we are going to discuss the inelastic collision. Are you getting or not? So what the definition you may write, I am not writing. When the during the reformation, some potential energy remains in the body and there is a loss of kinetic energy, that type of collision is called inelastic collision. Right? Inelastic collision. Inelastic collision. Loss of kinetic energy. Loss of kinetic energy occurs and some potential energy remains, right, remains inside bodies during reformation. That's it, right? So this is the m1 moving with the speed u1, right, and this is the m2 moving with the speed u2 before collision. After collision, the speed become v1, speed become v2, right? So this is the before collision figure, this is the after collision figure. Listen one thing, if you consider there is since no external force in the x direction, right, therefore the linear momentum remains conserved. So m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This is the equation number 1. Are you getting or not? This is the one equation we get. The another equation, listen, when this collision occurs, right, so the completely reformation does not takes place, right? So if you consider before collision, this is the u1 minus u2. What is this? u1 minus u2 is the, say, velocity of approach. Well, what is the velocity of approach? This is the relative velocity with respect to which the m1 is approaching towards the m2. So this is called the velocity of approach, and after collision it become high, v2 is greater than v1, and v2 minus v1 is called the velocity of separation. Is it clear or not? So for the elastic collision, velocity of approach and velocity of separation were equal, but in this case we define the coefficient of restitution. What is the coefficient of restitution? It is represented by E. It gives the extent of the elasticness or the inelasticness of the collision. E is the ratio of velocity of approach divided by velocity of separation. That is, E is equal to what? Velocity of approach is u1 minus u2 upon v2 minus v1. This is the coefficient of restitution defined in terms of velocity of approach and velocity of separation. For elastic collision, for elastic collision, we have found the E is equal to 1 is equal to u1 minus u2 upon v2 minus v1. You can check the derivation. We have found the relation u1 minus u2 is equal to v2 minus v1. Right. So this is for the elastic collision, but in this case, this ratio is 1. But in this case, this ratio will be less than 1. Right. So the value of E is always less than 1. Do you understand or not? You tell. Copy this. So the coefficient of restitution E, you will multiply u1 minus u2 is equal to E. एक मिनट रुको, मैंने गलत तो लिख दिया ये. is equal to what? Velocity of separation divided by velocity of approach आएगा. Wait for 1 minute. Wait for 1 minute. This is the u velocity of separation divided by velocity of approach. Wait for 1 minute. Please make it correct. Okay. So the coefficient of restitution is defined as velocity of separation divided by velocity of approach. v2 minus v1 upon u1 minus v2. Please make it correct. This is v2 minus v1 is equal to E u1 minus u2. This is the relation, right? So v2 is equal to what? v1 plus E u1 minus u2. If you put this value over here, right, and then you will get the v1 and v2 formula. Did you remember that I am not doing the so big calculation, right? The v1 and v2, I am direct writing the formula. What is the formula? Say m1 minus E m2 upon m1 plus m2 u1 plus m2 1 plus E divided by m1 plus m2 into u2 vector, and it is interchange. This is m1 1 plus E upon m1 plus m2 into u1 vector, right, plus it is also interchange m2 minus E m1 upon m1 plus m2 into u2 vector. So these are the formula for the final velocity in case of inelastic collision. Please make it correct. This is the coefficient of restitution, velocity of separation divided by approach. So from here the v2 you will get, and this v2 value if you put over here, right, and when you simplify this, the v1 you will get. I'm not doing the calculation. I suppose you have done this. If you need, you can tell me. And then when the v1 is, you find the v1, you can put in this case, and then you will get the v2. You have to remember this v1 and v2 formula for solving the question. Did you get this formula? Tell me. So we can do one question. For example, if we have, this is the 2 kg mass, this is the 2 kg, and it is moving with the speed 10 meter per second. This is the 1 kg, right, it is moving with 5 meter per second, right. If the coefficient of restitution is 1 by 2, find velocities after collision, velocities after collision, right. So this is the simple question. So you have to remember this formula. I have remembered, right. So the formula you can write, this is what? v1 is equal to m1 minus em2 upon m1 plus m2 u1 vector, m2 1 plus e upon m1 plus m2 into u2 vector, right. So this is the m1, this is the m2. 2 minus 1 by 2 into 1 divided by 2 plus 1. The u1 vector is 10, right, plus m2 1 plus e 2 plus 1 into 5. So this is 3 by 2 into 3 into 10 plus 3 by 2 into 3 into 5, right. So this is 5 plus 2.5 is equal to 7.5 meter per second, right. This is the v1. In the same way, can you find the V2? Let me check. The V2 is M1 1 plus E upon M1 plus M2 into U1, and this is M2 minus E M1 upon M1 plus M2 into U2. So M1 is 2, 1 plus 1 by 2, 2 plus 1, it is 10, 1 minus 1 by 2 into 2, right? And this is 2 plus 1 into 5. So it is 0. 2 into 3 by 2 into 3 into 10. Is it how much it is? 10 meter per second. Is it clear or not? Yes. So this is 10 meter per second is the correct answer. Right? Copy this. For example, if this is the mass m, this is the mass m, is at rest, it is moving with the speed u, right? So find first v1 and v2. Its velocity is v1 and v2. Ratio you have to find after collision, right? Consider the coefficient of v1 and v2 after collision. Second, if kinetic energy of balls after collision is 3/4 of 3/4 times of initial kinetic energy, find coefficient of restitution. This is the question. All right, copy this so that you can remember m minus m2 upon m1 plus m2, u1 plus m2 1 plus e upon m1 plus m2 into u2. v1 v2 is equal to m1 1 plus e. It is here only the m1 and m2 are interchange, m1 plus m2 into u1 plus m2 minus e m1 upon m1 plus m2 into u2. Here the u2 is 0, so it is at rest. Is it clear or not? Also listen one thing, the m1 and m2 both are equal, so here the m1 minus e, m plus m, 2m into u. So this is equal to 1 upon e by 2 into u. This is the v1. In the same way, m1 and m1 and m2 both are equal, 1 plus e upon 2m into u, right? And this is 0, so it may be written as 1 plus e upon 2 into u. So this is the v1 and v2. So the first part, the v1 upon v2 ratio they are asking. So what is the v1? Say 1 minus e upon 2 into u divided by 1 plus e upon 2. So the ratio is 1 minus e upon 1 plus e after collision. Is it clear or not? Copy this. So in the second part, we have to find the coefficient of restitution such that the kinetic energy of the balls after collision is the 3 times of the initial energy. Listen one thing. After collision, what is the velocity of this ball? Its velocity is v1. This is the velocity. After collision, what is the velocity of v2? This is the velocity. All right. So the kinetic energy of the balls after collision, that is half m v1 square half m v2 square is equal to 3/4 times of the initial kinetic energy. What is initial kinetic energy? Half mu square. Is it clear or not? Right. So the half m will cancel out. v1 square plus v2 square is equal to 3/4 or u square. And what is the v1? This is 1 minus e upon 2 into u whole square it is, plus what is the v2? 1 plus e by 2 into u whole square, It is 3 by 4 u square. Is it clear or not? So the u square term will cancel out 3 by 4. Here 1 minus e whole square by 4 plus 1 plus e whole square by 4. Is it clear or not? So the 4 will cancel out. So 1 square plus e square minus 2e. 1 plus e square plus 2e is equal to 3. So e square plus e square, it is 2 square. It will cancel out. So plus 2 is equal to 3. Right. So this is 2 square is equal to 1. E square is equal to 1 by 2. E is equal to 1 by root 2. So this is the coefficient of restitution for this type of collision. Copy this. Right. Any doubt you want to ask here? Listen. Okay. For example, suppose this is the big body and this is the small body. Coefficient of restitution is E. Are you getting? As I told you, this is the u1 and this is the u2. So what are the velocities after collision you have to find, right? The concept. v1 is equal to m1 minus em2 upon m1 plus m2 into u1 plus m2 1 plus e upon m1 plus m2 into u2. Is it clear or not? This is the m2. And what is the v2? m1 1 plus e upon m1 plus m2 into u1 and m2 minus em1 upon m1 plus m2 into u2. This type of the question, when an elephant hits the ant, you will get in the inelastic collision also, right? So here the v1 is what? You will write it is m minus em upon m plus m into u1 plus a small m 1 plus e upon m plus m into u2. Is it clear or not? So you will see that small m is small m. So this is what? Say u1 plus small m is 0 approximately, very less than. So it is 0. Again, in this case, the velocity of the elephant does not change. What does it mean? That is, after collision, the elephant will move with the same velocity as it is initial before the collision. Do you understand this thing or not? Copy this. Ant, you tell. The V2. V2 is small m upon, wait for 1 minute. This is the capital M. And this is 1 plus c upon m plus m into u, right? Plus small m minus a into capital M, m plus m into u2. Is it clear or not? So the v2, I will ignore this. So this is 1 plus e into u2, right? And I will ignore this. This is u1 and this is minus e into u2. This is the thing. So you have to remember this way. Are you getting or not? This is the u1 vector, this is the u2 vector and the v2 vector. So if inelastic collision is there and coefficient of restitution is given, so in terms of E, you can do in this way. Is it clear or not, you tell? Varshad, here the M can be ignored, M and M will cancel out, minus E will left. Copy this. Okay, so listen one thing. For completely inelastic collision, for perfectly inelastic collision, right? Perfectly inelastic collision. What is the meaning of the perfectly inelastic collision? You tell me. After collision, they are combined, right? And they move with the common velocity. Are you getting or not? So if u1 minus u2 is the velocity of approach and v2 minus v1 is the velocity of separation, so what is the separation velocity, you tell? They are not separated. When they combine, after combined, no reformation takes place. After deformation, no reformation takes place, and therefore because v1 and v2 both are equal, so velocity of separation is 0. So E is the ratio of the velocity of separation divided by velocity of approach. Velocity of approach. v2 minus v1 upon u1 minus u2. This is 0. Therefore, coefficient of restitution is E. For perfectly inelastic collision, coefficient of restitution is what? Say E. There E is equal to 0. Therefore, v1 and v2. Right. If coefficient of restitution is E is equal to 0, so what is the common velocity? So either you can find with the help of the formula, or also you can directly write down that m1 u1 plus m2 u2 is equal to m1 plus m2 into v dash. So this is the common velocity you can find, or m1 minus em2 upon m1 plus m2 into u1, m2 1 plus e upon m1 plus m2 into u2. Put e is equal to 0. So if e is equal to 0 here, m1 u1 upon m1 plus m2. E is equal to 0 mean m2 u2 divided by m1 plus m2. So the v1 velocity you will get m1 u1 plus m2 u2 divided by m1 plus m2. In the same way, the m1 1 plus e upon m1 plus m2 u1, m2 minus em1 u2, and put here the E equal to 0 because perfectly inelastic collision. Again E is equal to 0, E is equal to 0, m1 u1 divided by m1 plus m2, m2 u2 divided by m1 plus m2. So again the v2 is also equal to the m1 u1 upon m2 u2 divided by m1 plus m2. So this velocity is v dash, right, and this velocity v1 is also equal to the v dash, right. This is the same velocity v dash you will get. Either you can write down the conservation of momentum, the common velocity you will get, or you can apply also the formula, but here in the formula you have to put E equal to 0 for perfectly inelastic collision when they will move together. Are you getting, Varshaz? For this question, we have the hemisphere, right? This is the hemisphere, and this hemisphere is of what? Is the mass 4m, right? And here the one small block is placed over this. The radius of hemisphere is r, and it is placed on a smooth plane, right? So what happen if you give a small impulse or a small tilt? So what will happen? It will move towards this on the surface, right? And therefore it will move like this. Are you getting or not? Like this, right? So after some time, what will happen? It is moving like this, right? And this 4m will be relative to ground, will be moving with the speed v. Are you getting or not, you tell? So we have to find the angular velocity of the particle relative. If you sit over there with respect to sphere, what type of the motion of this particle is? It is moving along the circumference of the hemisphere. Are you getting or not? So with respect to hemisphere, it is performing circular motion. It is performing circular motion. So this angular velocity we have to find. Are you getting or not? You understand the question? Listen, if it is fixed, so when it will move, so what will it do? It will perform the rotation motion, or you can say circular motion, with respect to the hemisphere, but it is also moving. So first I am assuming with respect to what is the omega. Omega is the angular velocity with respect to hemisphere, right? So if this is the angular velocity, what is the speed? The v2. This is the speed v2. And v2 is equal to what? Say r into omega. Are you getting or not? Suppose if any particle is moving with angular velocity omega, radius is r. So what is the what is the linear velocity with respect to this? You tell. This is v is equal to r omega. Are you getting or not? So what is the v2? v1 is the speed of the hemisphere with respect to ground, right? This is the question of the relative velocity actually with respect to ground. Is it clear? What is the v2? Can you tell me what is v2? Any one of you? v2 is the linear velocity. v2 is the, if you are sitting over here, what is v? v is the linear velocity with respect to this point. If you are sitting over here, v2 is the linear velocity of block of m with respect to sphere. Are you getting or not? You tell. Right? So this is the v1, this is the v2. So now listen one thing. What is happening? Can you tell what is happening? This velocity and this velocity is coming with respect to what? Because of what? Because the height, right? Because of decrease in the potential energy. Are you getting or not? So what is this h? H is, this is r cos theta. So h is equal to what? R minus 1 cos theta. Is it clear, Varshas? Right. So decrease in the potential energy is mgh, which will be converted into kinetic energy. But this is the little bit tough question. It may be the tough. Why? Because the this is the velocity of this hemisphere with respect to what? Ground. But this velocity v2 is not with respect to ground. Are you getting or not? So if I assume this is the particle A and this is the wedge B. So what is v2? Linear velocity. This is the velocity of A with respect to B. Is it clear or not? But we have to find the velocity of A with respect to ground. So how to find? I am giving you very easy method to find the velocity of A with respect to ground is equal to velocity of A with respect to B plus velocity of B with respect to ground. Is it clear or not? You tell. Right. So velocity of A with respect to B. If this is the point, what is the velocity of A with respect to B? This is the velocity of A with respect to B. Right. Plus velocity of B with respect to ground. And this is the V. This is the V2. So the resultant of these two velocity, like this. This is the velocity. It will be the velocity with velocity of particle A with respect to ground. This is the velocity of A with respect to B plus velocity of B with respect to ground. The resultant vector will be velocity of A with respect to ground. Is it clear or not? You tell. Should I explain this once again? Should I repeat it? Okay. So how to find the resultant of two velocities? If this is the v1 vector, this is the v2 vector. So what is the angle between them? Can you tell? What is the angle? Say it is theta, right? It is theta, it is 90 minus theta because it is theta. So what is the angle between them? It is 90 plus 90 minus theta. So this angle is 180 minus theta. Is it clear or not? So what is the resultant velocity? The resultant velocity will be equal to the velocity of A with respect to ground is equal to root over v1 square plus v2 square plus 2v1 v2 cos 180 minus theta, and it is equal to v1 square plus v2 square, and it is minus 2v1 v2 cos theta. So this is the velocity of A with respect to ground. Is it clear or not? And what is the velocity of B with respect to ground? The v1 is the velocity of B with respect to ground. This is the answer. Are you getting or not? So now I can apply the conservation of energy. What is that? The decrease in the potential energy converted into its kinetic energy. What is that? Half m v1 square. Okay, in this question, this is given as v. This is given as, the hemisphere has become v. This is given as v. So half m v square, and the mass is equal to 4m plus half m VAB square, VAG square. Is it clear, Varsha, or not? You tell. M will cancel out. The 2GH is equal to 4V square plus VAG square. VAG square means V1 square plus V2 square minus 2V1 V2 cos theta. V1 mean, what is the V1 mean? V1 mean V. So this is the V square, 2GH is equal to 4V square plus V square plus V2. Okay, so V2 we have to find. V2 square minus 2V into V2 cos theta. This is 2GH. This is what? 5V square. Okay, one more thing will, wait for 1 minute. One more thing will be there, because we have what? We have the conservation of momentum also. Right, in horizontal direction, we have the conservation of momentum. So although it is correct relation, wait for 1 minute, V2 square minus 2V, right, V2 cos theta. This is the correct relation, no doubt. Yeah, we can substitute, but the answer we are not getting so easy, because it will be the quadratic equation. Are you getting or not? So this is the conservation of energy, it's fine, but one more thing we can apply, and that is the conservation of linear momentum in x direction. And what is that? Listen, if this is the speed with respect to ground, so this is 4m into v1, all right, it's linear momentum, and its linear momentum is in this direction. So listen one thing, if this is the v2 with respect to sphere, and this is theta, 90 minus theta, this is theta, so this speed is v2 cos theta with respect to what? With respect to sphere. So with respect to ground, the speed, the velocity with respect to ground in x direction will be, this is v2 cos theta and minus v. So in this direction, this is the velocity, right, with respect, this is the velocity with respect to ground in horizontal direction, and definitely v2 cos theta minus v will be greater. So one more equation we can get from the conservation of linear momentum. m1 v1 is equal to m2 v2. 4mv is equal to m into v2 cos theta minus v. Will cancel out. So 4v is equal to v2 cos theta minus v is equal to 5v into v2 cos theta. Right? So what is the v2? v2 is equal to 5v cos theta, right? And what is the relation? v2 is equal to r omega is equal to 5v cos theta. So I think it is simple now. The angular velocity is this. So it can be found this. Although when you will find the answer of the v2 from this quadratic equation, you will get the same answer. This is the question of the center of mass. That is why we are using this concept, right? No need to do this, although it is also correct, by conservation of energy. Are you getting or not? Right. Listen one thing. I'm giving you an illustration. For example, if this is 4m and this is m, suppose it is at rest and it is moving with v cos theta in this direction, right? And it is at rest. So what is the velocity of the particle m with respect to ground? Only the v2 cos theta. But if it start is also moving towards this, then with respect to this, the particle is going v2 cos theta, but it is also moving toward this, so its speed will reduce. So this is the resultant of these two components will be the velocity with respect to ground, which comes to be v2 cos theta minus v. Now you understand this? Copy this, copy this. You should skip this. Yes, please. Yes, that's the thing. Listen, when I was using conservation of energy, the net velocity I was tried to taking, but in the question G is not coming, right? So one another option is there. We can apply the conservation of linear momentum. When you are applying the conservation of linear momentum, you have to apply with respect to ground, because with respect to ground, this system is at rest in x direction. So when you are applying the conservation of momentum, right? So you have to take this conservation of momentum with respect to ground. It is, so with respect to ground, it is the speed I have considered, which is given in the question. So I have to find its speed or velocity with respect to ground. So how to find? First, assume that it is moving with angular velocity omega with respect to hemisphere. So what is the velocity of this particle with respect to hemisphere is v2. So in this direction v2 cos theta, in this direction v2 sin theta. But this hemisphere itself moving towards right, left. So what is the net velocity of this small m with respect to ground? v2 cos theta minus v, right? So that is the thing. Okay, one question I am asking, right? Sometime this is the block, if it is moving with 10 meter per second, right? This is the angle 53, and with respect to hemisphere, this is moving with 10 meter per, this is moving with 5 meter per second, right? This is the m1, this is the m2. Can you find the velocity of m1, with respect to ground? Please find. This is the question. This is the velocity with respect to ground. It is given in the question. This is the velocity with respect to hemisphere, right? So you have to find the velocity of m1 with respect to ground. Listen, you sit on this. First, find its component in x and y direction. If this is 53, 53, 37, 53. So this component is 5 cos 53 and this component is 5 sin 53. Sin 53. Is it clear or not? Right? Right. So with respect to this, it is moving with 5 cos 37, 5 cos 53. Cos 53 is what? 3 by 5. Right? It is 53, yes. 5 into 3 by 5. So it is 3 meter per second and it is 4 meter per second. So with respect to sphere, it is moving in this direction 3 meter per second and it is moving in this direction 4 meter per second. Are you getting or not? So to find this is the velocity component with respect to hemisphere. So with respect to ground, if you want to find, so what you have to do, you tell. This 10 meter per second should be added to this velocity component. Is it clear or not? Should I explain this? How does it as added? Right. So, and then you can find the resultant. This is the 4 meter per second in this direction. And this is what? 7 meter per second in this direction. In x direction, this is the component. In y direction, this is the component. So, what is the resultant velocity with respect to ground? The resultant velocity with respect to ground is 4 square plus 7 square plus, but that's it. Right? So, this is the answer. Do you understand the concept or not? 5 meter per second. So this is the speed of the m1, speed of m1, speed of m1 or velocity you can say with respect to ground. That is the thing. All right. In x direction, the velocity of this is 7 meter per second, this is the 4 meter per second. So this is the easy way to find the velocity of some block with respect to ground if it is moving with relative to some other block. Copy this. So in this question, right, suppose there is a wedge of the mass m, this is the mass m, the height h is over there, right? Another wedge is also placed over this, right? This is the wedge A or C, whatever you call this, right? This is the C of the mass m, this is the B of mass m, this is the A of mass m. So when it will fall down from this, it will move. So after some time, when it is completely descend, so this is the m, it is moving with the speed v1, it is moving with the speed v2. Are you getting or not? So what is the relation between mv1 is equal to mv2 using the conservation of energy? It means the speed of each block will be v when they are moving in this way. Are you getting or not? You tell. And conservation of energy, applying the conservation of energy is equal to half mv square plus half mv square, right? So mgh is equal to mv square, will cancel out, so v is equal to root gh will be its speed when it is moving towards this, right, like this. So it will continue to move, it will try to ascend, right, and it will be moving like this. When it will touch this, it will also start, this C will also start moving with some velocity v. So finally, listen one thing, when it is ascending, right, here it is descending, here it is ascending. So at the maximum height, what happened, you tell? When the maximum height is condition is achieved, when both block, this block m stop with respect to this block, right, with respect to this block, if it is stop to move ascending, right, it to move up, right, in that case, suppose the speed is v dash and the speed is v dash. Are you getting or not? What is the condition of maximum height attained? If this A block stop moving with respect to this inclined plane. So in that condition, with respect to C, what is the speed of A? Say 0, and it is also itself moving with the speed v dash. So with respect to ground, v dash, it is moving with v dash, it is also moving with v dash. So initial momentum, now we will consider this system. The initial momentum is mv and the final momentum is mv dash. So this is mv is equal to 2 mv dash and v dash is equal to v by 2. Are you getting or not? So v by 2, what is the v dash? V by 2, and this is equal to what? Gh by 2. Are you getting or not? So in this case, what is happening, you tell? All the blocks achieving the kinetic energy, right? So how this kinetic energy is attained? Or either you can apply now the conservation of energy from A and C. This is moving, so apply the conservation of energy, its kinetic energy is converted into, in what? its kinetic energy half mv dash square plus half mv dash square, and its potential energy plus mg h dash. The height attained is h dash. Definitely this h dash will be less than this h. Suppose this is the h dash. Are you getting or not? So m will cancel out. So v square. So what is the speed attained by the block A? This is gh by 2 v dash square plus v dash square. It become 2 gh dash. Right? And what is the v dash square? V dash square is v by 2 whole square, gh dash v square by 4, gh by 2 plus gh dash. What is the v square? Say again it is gh by 4, gh by 2 plus gh dash. Gg will cancel out. H by 2 minus h by 2 minus h by 4, right, is equal to h dash. So h by 4 is equal to h dash. So h dash is 100 upon 4 is equal to 25 centimeter is the final height rise by. So in this question, comprehension 3 it is. This is the m and these are the two blocks of the mass 2m. Initially they are moving towards right with the initial velocity v naught. So the collision is completely inelastic. What is the inelastic collision? Can you tell? The inelastic collision. In inelastic collision, suppose this is the m1 moving with u1 and the m2 moving with u2. Although I did not teach you, but I am telling, inelastic collision today we will start when they will collide. U1 is greater than u2. They both body combine together and move with the common velocity. Are you getting? This is called the perfectly inelastic collision, such that m1 u1 plus m2 u2 is the initial momentum is equal to m1 plus m2 is equal to v dash. So this is the common velocity. In perfectly inelastic collision mean after collision the two bodies are stick and they will move with common velocity together. This is the meaning of the inelastic collision. Are you getting or not? So when this body, right, collide with the body, another body 2m of the C, right, it is at rest. So in the first part they are asking what is the speed just after collision of block B. This is A. So this, the collision occurs between 2m and 2m at rest. So what is the initial velocity? So initial velocity is v naught. When the inelastic collision occurs, so they combine and become 4m mass. Do you understand or not? You tell. So what is the v dash then? So for, if you consider this is the system, the initial momentum is 2m v naught plus 2m into 0. And what is the final momentum? They become combined body and move with common velocity v dash. So 2m v naught is equal to 4m. So v naught by 2 is the v dash. While this speed, this velocity, this block continue to move with the speed v naught. And this is the what? The v dash become v naught by 2. So this is the first question answer, right? The velocity of this velocity of the particle of B with become v naught by 2. Is it clear or not? You tell. Right? So B option is the correct option. Is it clear or not? Right? And the second option, the velocity of center of mass. So velocity of center of mass you can find easily, right? What is that? VCM is equal to m into v naught plus 2m into v naught plus 2m into 0 divided by m plus 2m plus 2m. So this is 5m, right? And this is 3m v naught, and the answer will be 3m v naught by 2. So this is the velocity of center of mass. Are you getting or not? And they are asking the maximum compression. So we can find. Listen, For this, I have given you the formula, very important formula or result you can say. So if these are the 2-point mass system connected with the spring, the V naught by 2, it is moving with V naught by 2. So what is the relative velocity initial? Say V naught minus V naught by 2. Is it clear or not? What is the reduced mass? Say m1 m2 upon m1 plus m2, m1 upon 4m. So this is 4m upon 5. Is it clear or not? The spring constant is k suppose. So the relative reduced mass kinetic energy is equal to half k x max square. Is it remember or not? You tell. So initially it is moving, it is compressing, its velocity will increasing, its velocity reducing. Finally, when the maximum compression occur, so they are moving with the common velocity. In this case, I am finding the x max. So from this formula, we can find what is the reduced mass, say 4m upon 5. What is the relative velocity, say v naught by 2, right, is equal to k into x max square. So here you can find 1 upon 5 m v naught square by k is equal to x max square. So the x max maximum compression is equal to mv naught square, right, upon 5k should be the correct answer. You can check the answer. The B option of the third part is the correct answer. Copy this.